Assalamualaikum and welcome to the second part of the video on conclusion from study of a particle in one-dimensional box. In our previous video we have read about 5 conclusions, and now in this video we are moving forward from 6th conclusion. The 6th conclusion says that we have eigen wave functions. It means that the wave function of a particle in a one-dimensional box is given by, as you know, the value for the wave function in a one-dimensional box is this. Okay, you know the value for wave function in one-dimensional box is this. So here, as you can see, there is a value n. Okay, and n can have a value from 1 to 3. There is a variable n that has a value of 1, 2, 3 and so on. It means that if I put the value 1 here, my answer comes out to be psi is equal to under root 2 over a sine pi x over a. If I put 1 here, the n vanishes. Okay, so if I put 2 here, the answer will have a 2 in it. If I put 3 here, the answer will have a 3 in it. Okay, so if I say that I put 2 here, if I put 1 here, the answer comes out to be under root 2 over a sine 1 pi x over a. And if I put 2 in place of n, then I have 2 over a sine 2 pi x over a. Similarly, if I put 3 here, I will get a 3. So as you can see that these wave functions are discrete wave function. Okay, the wave function cannot have any value between this and this. Okay, the wave function cannot have any value between 1 and 2, 2 or 3, 3 or 4. Okay, the wave function cannot have value in between, but wave function can have the value of 1, 2, 3, 4 integral multiple. Okay, so the thing is that such discrete wave functions, okay, such discrete wave functions, okay, are called the eigen wave functions. These are known as the eigen wave functions. Okay, or acceptable wave function. Another name for this is acceptable wave function. And the last thing is that they are also known as the well-behaved wave functions. Okay, these are also known as well-behaved wave function. So that was the 6th point. Moving on towards the 7th point. The 7th point is the forms of wave function. Okay, so forms of wave function. According to this, if I plot a graph of psi with the displacement, okay, if I have the graph of psi along with the displacement from x is equal to 0 to x is equal to a, it will have a form just like this. Okay, so graphical representation of psi n are exactly like those showing the displacement of a vibrating string clamped at x is equal to 0 and x is equal to a. Okay, so what I am describing is that the value of psi, the graphical representation of psi, is just the same as if a string is attached between the two walls, is clamped between the two walls. Okay, from x is equal to 0 to x is equal to a. Okay, so what I'm going to describe here is that if I have a psi just like this for n is equal to 1, okay, if my energy increases, okay, n is equal to 1 has lower energy, n is equal to 2 has more energy, n is equal to 3 has more energy. As you know that when my energy increases, the wavelength decreases. As you know the formula for energy, the formula of energy is E is equal to hc over lambda, which says that if my energy increases, the lambda decreases. Okay, so as you can see here, the wavelength is very large because it has energy very low, because at psi 1 we have a lower energy known as the 0 point energy, and if I have n is equal to 2, the energy increases. More energy means lesser wavelength. Okay, so here the wavelength was very large, and in this case the wavelength has reduced. Okay, the wavelength starts from here and ends here. If I take n is equal to 3, the wavelength starts from here, here is the wavelength crest and here is the wavelength trough, so here the wavelength ends. Okay, so my wavelength is reduced as energy is increased. So I can say that on increasing the value of n, the energy increases and the wavelength decreases. So as you know that if the energy has increased, then the wavelength has automatically decreased. It has a wavelength, it has a very large wavelength. Since it has the energy very low, psi 1 has a low energy. At n is equal to 1, the energy is lowest. So I can say that here the wavelength is very large. and here the wavelength has reduced, and here the wavelength has further reduced. So moving on, if I take psi square, as you know that psi square is the probability of finding a particle in a given space. So as you can see that psi square here is just like this as was psi, but psi 2 square is different from psi 2. As you can see that here psi had a positive value and negative value, but as you know that if I take square, the negative value also become positive. In case of square, the negative becomes also positive, so here it is the positive value. So I can say that psi square is always positive. Psi square is always positive, mean the probability of finding the particle is always positive. And if I compare the third, here third had this negative value, but in case of psi square this negative also become positive because minus minus becomes positive. Okay, so the next thing is that the probability of finding a particle in a box is delocalized. What does it mean that the probability of finding a particle in a box is delocalized? It means that for n is equal to 1, if I talk about this, for n is equal to 1, the probability of finding the particle, the maximum probability of finding a particle is here at x is equal to a by 2. Okay, so now if I talk about the probability of finding a particle for n is equal to 2, the maximum probability of finding the particle is here and here, because here the probability is again 0, here the probability is 0, here the probability is 0. This point here is known as node, this point here is known as node, and this in n is equal to 1 we have no nodes, while in n is equal to 2 we have one node in the center. For n is equal to 3 we have 1, 2 nodes. Okay, so for n is equal to 3, where will be the probability of finding the particle maximum? The probability of finding the particle maximum will be here, here and here. Okay, it will be maximum at the maxima here. Okay, so the next thing is for n is equal to 1, the maximum probability is at x is equal to a by 2. For n is equal to 2, the maximum probability is at 2 points, x is equal to a by 4 and 3a by 4. Okay, so the next thing is for node, probability is 0. At node the probability is 0. For node the probability is 0. So if number of nodes increase, okay, if number of nodes increase, just like this, we have 0 nodes here, we have 1 node here, we have 2 nodes here. So when the number of nodes increase, the curvature also increase. What does it mean, the curvature increase? For example, let's just talk about this. Here it was, this curvature was just like that, and here we have got 2 curvatures. Okay, and here what we have 1, 2 and 3 curvatures. Means on increasing the number of nodes, the number of curvature increases and the wavelength decrease. As you have read earlier that the wavelength is decreased, and on decreasing the wavelength, as you know that E is equal to hc over lambda, and if wavelength is decreased, the energy has automatically increased, so energy has been increased. Okay, so now we will solve an example on this. This is the question that we are going to solve, that for a particle n is equal to 1 moving in one dimensional box. So we have a particle at n is equal to 1 and it is moving in the box. So what we want to do is to calculate the probability of finding the particle anywhere in the region from 0 to a by 4. Okay, so what we are going to do is that if I have a particle at n is equal to 1, okay, I have a particle at n is equal to 1. So what I want to do is to find the probability of the particle at a by 4. Okay, what I want to do is to find the probability of the particle anywhere in the region from 0 to a by 4. What I want to do is to find the probability of particle from 0 to a by 4. So 0 to a by 4 means from 0 here to a by 4 here, to a by 4 here. Okay, so the next thing is, first of all, what we are given is that the particle is moving in one dimensional box. So for one dimensional box, we have psi, we have the value of psi to be equal to psi equal to under root 2 over a sine n pi x over a. So this is the value of psi for a particle in one dimensional box. So the next thing is, what we want to do is, since as you know that n is equal to 1 as we have been given here in the question, so this n will vanish. So I get a value of psi to be equal to under root 2 over a sine pi x over a. Okay, so the next thing is, I'm going to take the square. Since we are going to find the probability, so what we are going to do is take the square. So taking the square, I have to do under root 2 over a sine pi x over a square. Okay, so the square of this part will come out to be, square will cut down with this under root and square will go to the sign here, and the answer comes out to be 2 over a sine square pi x over a. So this is the value of psi square, the probability of finding the particle. So the next thing is, what we are going to do is to take the integration on both sides, since we are finding the probability. So I have to take an integration on both sides. On taking the integration on both sides, what will happen? I'll have psi square, since my range is from 0 to a by 4, so here is 0 and the upper range is a by 4, and it will be equal to, since 2 by a is a constant, it will go out of the integration here, and the rest is 0 to a by 4 within the integration sine square pi x by a. Okay, so here what I've done is just taking the integration, and here is dx and here is dx of the integration. So the next thing what I'm going to do is just to plug in a formula here. So the formula that I'm going to plug in here is of sine square x. So if I have something like sine square x, so how this sine square x will open? This sine square x will open just like this. Okay, 1 minus cos 2x divided by 2. So sine square x opens just like this. So here I have sine square pi x over a. So what I'm going to do is write this value here. So let's see what will be the answer. Sine square pi x over a will be equal to 1 minus cos 2, and in place of x what I'm going to write is pi x over a. Okay, so I have pi x over a in place of x, and here it is the 2 in the denominator. So what I'm going to do next is just to give 2 to this and this, separating it. So 1 by 2, this will become 1 by 2, and minus 1 by 2 cos 2 pi x over a. Okay, so this is how my formula of sine square pi x over a has opened. So what I'm going to do next is just to plug in this value here. Okay, so moving on, I'll write at 2 over a. Okay, and here what I'm going to do, 0 a by 4. This formula has opened to become 1 over 2 minus 1 over 2 cos 2 pi x over a, and I have d of x here. So the next thing that I'm going to do is to apply this integration here and apply this integration here. Okay, and this dx will also be distributed to both. Okay, so the next thing is, since this 1 by 2 is a constant, so it will go out of the integration. So this 2 by a is the whole multiplied. Here 0 by a by 4, 0 to a by 4 integration when applied on 1 by 2 gives me an answer 1 by 2, 0 to a by 4 and dx. Okay, 1 dx. Since 1 by 2 was a constant, so it has gone out of the integration. Here the next is sign, has a sign of minus, and 1 by 2, since another of the constant, it will also go out of the integration. This integration will apply here, 0 to a by 4, and I have cos 2 pi x divided by a. Okay, and this dx will also be applied here, and I have a bracket closing for 2 by a. Okay, so the next thing what I'm going to do is just to apply the integration. Okay, the integration of cos 2 pi x by a, for cos 2 pi x by a will come out to be just like this. So if I have an integration cos 2 pi x over a, this integration will open to become this a by 2 pi. Okay, what we are going to do is taking the reciprocal here, and this a over 2 pi will get out of the out here, and this cos has a integration equal to sine. Okay, this cos will become sine, and this 2 pi x over a will still be here. This is the formula for applying the integration on equations such as this. Okay, so this formula, we are going to follow this formula here, and we are going to apply this value here. Okay, so I have 2 over a, and I have 1 by 2 here. The integration of 1 dx, what is the integration of 1 dx? The integration of 1 dx follows the form, if I have this integration, I can write 1 to be equal to x0 dx, and the integration of x0 becomes x1 by 1, okay, which is equal to x. Okay, you know the formula for integration, that if I have an integration of xn dx, then this integration opens to be equal to xn plus 1 divided by n plus 1. Since I had here 0, so 0 plus 1 becomes 0, and divided by 0 plus 1, 1, and I get an answer equal to x. So this was the basic formula for integration. So what I'm going to do next is just to plug in the values. So the integration of 1 dx comes out to be x, and here I have a limit condition from 0 to a by 4 minus I have 1 by 2 here, and the integration of this form I have calculated to be equal to here. Okay, so what I'm going to do is just to write the formula a over 2 pi, just write the answer a over 2 pi sine 2 pi x over a. Okay, thing that you know is that we have a limit here from 0 to a by 4. So what we are going to do is just to apply the limit. As you know that when we apply the upper limit here 2 by a, and when I apply the upper limit in place of x, the answer comes out to be 1 by 2 divided by multiplied by, in place of x I am going to write a by 4. Okay, and 0. What if I put the value here 0? When I put the value 0 here in place of x, then this part of the equation becomes equal to 0. So I'm not going to write the 0 part here. Okay, so the next thing is minus, and the next thing is here 1 by 2, and here when I put first of all I have to put a by 4 in place of x. So first of all I have a over 2 pi. The next thing I have sine 2 pi. In place of x I am going to write a over 4, a over 4, and I have a here. Okay, and when I apply the lower limit 0, as you can see that if I apply 0 here, then this equation, this part of the equation also becomes 0. So what I'm going to do is just neglect this form. Similarly, when I applied 0 here, I had neglected this part, and when I applied 0 here, I had neglected this part because this part comes out to be equal to 0, just like when 0 was put here. Okay, so the next thing what I'm going to do is a will cut down with this 2 will cut down with this answer become pi by 2. Okay, 2 over a, and I have a by 8 minus 1 by 2 to 4, 1 by 4 pi. I have a. Okay, this a1 multiplied by a forms a, and I have sine, I have pi by 2. Okay, as you know pi by 2 is 90 degrees, so sine 90, as you know that sine 90 is equal to 1, so this part becomes equal to 1. So what I get an answer is 2 over a by 8 minus a by 4 pi, and sine pi by 2 becomes equal to 1. So here next thing, multiply this 2a, 2 multiplied by a becomes 2a, and a multiplied 8 becomes 8a. Similarly 2 multiplied a becomes 2a, and a multiplied by 4 pi becomes 4 pi a. So 2 1 the 2, this becomes 2 1 the 2, 2 4 the 8, and this becomes 2 1 the 2 and 2 2 the 4, and the answer comes out to be 1 over 4 minus 1 over 2 pi. Okay, so this is the answer, this is the probability of finding the particle in the region from 0 to a by 4. So this was my answer. So moving on towards the next point. So now our next topic is symmetry of wave function. What does it mean to have symmetry in wave function? First of all, what you need to do is to consider this diagram here, in which I have drawn psi along with the distance from x is equal to 0 to x is equal to a. As you can see, for psi 1 I have a single crest, for psi 2 I have a crest and a trough, I have a crest and a trough and a crest for psi 3, n is equal to 3 for psi 3, I have 1 2 3, a crest, a trough, and again a crest. Okay, so what does it mean to have a symmetric wave function? The symmetric wave function mean if I pass a mirror from the center, okay, the wave function divides into two parts such that the reflection of this part, comes out to be equal to this part. Okay, the reflection of both the part is same. For example, if I place a mirror here, as you can see that reflection of this part will be equal to this part, whereas if I place a mirror here, on placing the mirror here, the reflection of this part will not be equal to this part. Okay, if I have a reflection of this part, then it will come here. Okay, and the reflection of this down part will come here on the left hand side. Again I'm going to repeat it, that if I have this n is equal to, if I take n is equal to 2 here, the upper part will have a reflection on the upper part of the right hand side, whereas the lower part will have a reflection on the lower part of the left hand side. Okay, since the reflection will not be equal, it will be opposite, so I can say that psi 2 is anti-symmetric. Okay, where psi x is equal to minus of psi x, means that this part, the reflection of this part will be opposite to this part, and this part will have a reflection opposite to this part. Okay, we are not getting the exact reflection, means here that this part is not giving reflection here but at the down. okay, and this down part is not giving a reflection here in the down part, but it is giving the reflection in the upper part. So I can say that this is the anti-symmetric method. This is the anti-symmetric wave function, okay, and this here is a symmetric wave function. As you can see that this part is just equal to this part, okay, the reflection of both this part is same. And if I talk about this here, this is also the same. As you can see, here is my wave function, and if I take this part, it will have a same reflection just like this. So I can say that my even number of wave function, if I have a wave function with even number, say psi 2, psi 4, psi 6, then they will be anti-symmetric, okay. And if I have odd number of wave function, then odd number of wave functions, then they will be symmetric, okay. How they will be symmetric? As you can see, 1 3, the 1 is symmetric and 3 is also symmetric in itself, and similarly 5 will also be symmetric in itself, okay. So this was the symmetric and anti-symmetric wave function, okay. And you can see here that psi x is equal to minus psi minus x means that minus minus will cut down, and I'll get again get a psi x equal to psi x, means that this reflection is equal to this reflection, whereas psi x is equal to minus psi x means that I get an opposite reflection on the right hand side, okay. So the next thing is relation of n with lambda. The next conclusion from the particle in one dimensional box is the relation of n with lambda. As you know that the kinetic energy has a formula n square h square over 8 ma square. From here I can conclude that E energy is directly proportional to n square. I can say that E energy is directly proportional to n square, okay. So this was the formula of quantum mechanics. So if I talk about the classical mechanics, the kinetic energy has formula half mv square. So on taking here kinetic energy is equal to half mv square. So what I'm going to do next is just to multiply and divide it by m, okay. On multiplying and dividing it by m, my answer comes out to be 1 by 2 m square v square divided by m, okay. On multiplying and divided by m, my answer comes out to be just like this. And the next thing is m square v square becomes momentum, so this answer becomes equal to p square over 2m. As you know that momentum is equal to mv, okay. So next thing, as you can see that my kinetic energy is directly proportional to momentum, so I can say that my energy is directly proportional to momentum p, okay. And how it is directly proportional? By p square. So the next thing is, if I take the de Broglie hypothesis, the de Broglie hypothesis says that lambda is equal to h over p. This is the de Broglie's hypothesis that says lambda is equal to h over p. Here you can see that lambda is inversely proportional to the momentum, or I can say that the momentum is inversely proportional to lambda. So what I am going to conclude is that my lambda is inversely proportional to momentum. Now compare these three equations. As you can see that lambda is inversely proportional to momentum, okay, and momentum is directly proportional to energy, and energy is directly proportional to n square. So on combining these equations, I can write that lambda is inversely proportional to n square, okay. Since momentum is inversely proportional to lambda, and whereas momentum is directly proportional to energy, and energy further is directly proportional to n, so I can say that lambda is directly inversely proportional to n square, or I can say in general that my lambda and n are inversely proportional, okay. So the next thing the next thing is the length of one dimensional box is an integral multiple of wavelengths. So we are going to find this, so that if I have energy, as you can see that energy has a formula n square h square over 8 ma square in case of quantum mechanics, and it has a formula energy is equal to half mv square in case of classical mechanics, okay. So what I'm going to do next is just to plug in the value, just to multiply and divide this by m, and as you can see that what we have done here is multiply and divide by m, and we have got the value p square over 2m. We have just done the same, and we will get the value p square over 2m. So what we are going to do next is use de Broglie's equation. As you know that de Broglie says that lambda is equal to h over p, okay. So if I get p here, then it will become p is equal to h over lambda, and taking the square, it becomes p square is equal to h square over lambda square. So what I'm going to do is just to plug in the value of p square is equal to h square over lambda square here. So on plugging in the value of this, plugging in this value here, I get an answer E is equal to, in place of p square I'm going to write h square over lambda square, h square over 2m lambda squared, okay. So as you know that this energy and this energy, these both are the same according to quantum mechanics and classical mechanics. So on taking these to be equal, I can write as h square over 2m lambda square is equal to n square h square over 8m a square, Okay, so this h square will cut down with this h square, this m will cut down with this m, this 2 will cut down with this to form 4. So my answer that comes out to be is 1 over lambda square is equal to n square over 4a square. Okay, so in order to find a, the length of the box, what I'm going to write is, I'll take a here and lambda square here. The answer comes out to be a square is equal to lambda square n square over 4. So on taking the under root on both sides, a square will cut down, under root will cut down with this, and 4 have under root equal to 2. This answer comes out to be a, and taking the under root, the answer is lambda n divided by 2. So this is the length of the box A. So this is how we have proved that the length of the box is an integral multiple of wavelengths. This lambda is a wavelength, this n is an integer that has a value 1, 2, 3, so on. Okay, so here we have proved this, that the length of the one-dimensional box is an integral multiple of the wavelength. So that was the 10th point. So inshallah, see you in the next video with more points. So the next conclusions of the particle in one-dimensional box will be discussed in the coming videos. Okay, the link to the next video will be in the description box. So do not forget to like the video and subscribe the channel. Inshallah, see you in the next video. Allah Hafiz for today.